Okay, so hi, I'm Yoav Weiss. I work on the web platform for a bunch of years now. I started out as a hobby working on responsive images as part of the responsive images community group. Then continued to work on the platform as part of my actual day job at Akamai, and nowadays I'm part of the Chrome team working on evolving the platform and working on various web performance-related features. Throughout the years, I worked on, like I said, the responsive images features. Continued on with working on pre-connect, prefetch, preload, client hints. I spent a lot of time thinking about web performance-related stuff, related features, which you can imagine my excitement when towards the end of 2015, this AMP thing. And as someone who cares deeply about performance, I was both super excited as well as terrified by it. Because on the one hand, it was great to finally see performance getting the front stage by a major player pushing a framework whose main purpose is to make sites faster. At the same time, while the format was a subset of HTML and it was well documented, it had some parts in it that were less than ideal. It required an AMP JavaScript framework, which had to be part of that page, and also all AMP pages had to be served from trusted servers. So while it was great to see performance put at the focus of things, it seems like something that has a real risk of forking the web. So I remember sitting at TPAC, which is the annual W3C gathering, one morning at the end of 2015, and there were a bunch of presentations by the W3C higher-ups regarding the state of the web during that year. So obviously, I was checking out Twitter, and then I saw some AMP-related news coming in from folks that I previously known at previous TPACs as part of the W3C community. So I thought to myself that we need to come up with a standard alternative to AMP, or enable standards to have better ways to do AMP. And because we're talking about web standards, real quick here is relative. So here I am over 3 years later talking a bit about the native capabilities that we're adding to the platform in order to enable similar use cases to the one that AMP tackles. And this is very much an extensible web move because we're similar to the way that jQuery showed us that some of the DOM APIs are not so great and not so consistent, and encourage us to create better ones, and similar to the way that JavaScript frameworks and languages that transpile into JavaScript inform the evolution of the language and give us things like arrow functions. AMP, in a way, shows us that what pieces of the platform are missing in order for us to create great user experiences, in order for us to create instant user experiences. Here we are catching up. So when we think about those missing pieces, one large part of it is privacy-preserving prefetch, which is a significant way in which AMP manages to get its performance boost. And it's so much significant that it's been called cheating. And AMP cheats because by the time that the user actually clicks on a link or clicks on a carousel page, most of that content, if not all of it, is already on the user's device. So a large part of the performance experience, like the loading performance experience, is shifted to a time where we don't really care about its performance. It's shifted to a time where the user doesn't actually spend their time staring at the screen. So, and it's not that we don't care about loading performance beyond prefetching, but we don't care as much. It removes the bottleneck from where it currently is. So this huge advantage is the reason why AMP has many of its current properties, including the fact that the content is served from Google servers, like at least AMP content that is served from Google search is served from Google servers and has the URL of Google servers as part of the URL bar in the browser. And because the reason for that is that, well, prefetching content, we want to make sure that the server is not aware of those prefetches happening, because we cannot let the servers know that a prefetch has happened before the user has shown intent to actually navigate to that page, because otherwise it runs a risk of leaking information about the user to servers they don't actively interact with. But as I already said, modifying the URL is not ideal. So there's a good chunk of capabilities that are missing here to enable us to have privacy-preserving prefetching on the web while still keep the URLs and the same origin policy and everything else that makes the web the web. The second part that AMP provides is content restrictions, which initially sounds like a bad thing, but it actually restricted content and a restricted format actually enable us to get guaranteed performance, because by restricting what AMP pages can do, what web pages can do, users are able to know that clicking on those links are not going to result in an awful experience in terms of performance. One example is that AMP pages are not allowed to load images in ways that make the layout jump around once the image dimensions come in, so that users don't get an experience of trying to click on a link or reading an article and then the content shifts and they have to find where they were or they clicked the wrong thing. That is something that currently is very hard to get right on the web and we need to fix. On top of that, AMP cannot load arbitrary JavaScript content into the page's mainframe, and arbitrary JavaScript has to be restrained to its own iframes, which is more performant and more secure. Images and text resources must be properly compressed, and all those restrictions are validated by two different mechanisms. One is the AMP validation mechanism, and the other is the AMP runtime. So everything that cannot be statically validated ahead of time is restrained by the AMP runtime at runtime. So, but this is the reason why AMP has to load JavaScript as part of, like the AMP JavaScript runtime as part of every AMP page in order to make sure that those restrictions are in fact applied. So we need new platform capabilities that will enable us to tackle those use cases on the web, that will enable us to have enable us to create similar experiences on the web without falling back to the solutions that AMP currently implies. So those capabilities are divided into three pieces. Content restrictions, privacy-preserving prefetch, and user-centric metrics in order to actually know once we have reached our performance goals, we need to know that we have done that. So let's dig in. So content restrictions. Back in 2015, after tweeting out that we need a better standard alternative, we started a discussion about content security-like mechanism that will enable to apply such content restrictions on the web. Funnily, multiple teams reached more or less the same name at the same time. And eventually I published a content performance policy as a draft and worked with Tim Cadillac, then a colleague at Akamai, on various discussions with the Chromium and AMP teams in order to push this concept forward. And after various discussions, we ended up breaking up that initial proposal into 3 pieces. One is feature policy, content size policy, and priority hints. Feature policy is a way for us to restrict certain features or restrict certain harmful features on the web. So we basically can tell the browser to turn off certain features that we know we're not going to use or that we know are harmful in order for us to avoid using them, in order for us to tell anyone that examines this content that we're not going to use that, and arguably most important, in order for third parties not to have access to these features that we consider harmful. So a couple of features that we had in mind initially were synchronous XHR and document.write, which are generally agreed upon that there are harmful features that shouldn't be, that wouldn't be a part of the web if we were starting things from scratch today. They have to be there for backward committability, but if we are able to tell the browser that the content will not use them, the browser can, in certain cases, even optimize the parser further and have a faster HTML parsing just because the browser knows that document.write is not going to be there. But as we thought more about feature policy, we saw more opportunities for us to expand that concept. So one area where we have a lot of where we focused on is improved image loading. Images on the web suffer from multiple issues. They're often too large dimension-wise, not properly compressed, are using legacy formats rather than newer formats that they could be using, which are generally smaller. And they often introduce the layout process problems that I talked about, where it's very hard to reserve space for images on the web today. And on top of that, we also have images today are loaded even if the browser doesn't really need to, even for images that are way out of the initial viewport and the user doesn't necessarily scroll to see them, the browser will download them. And this is often unnecessary. So a few feature policies that were worked on to basically tackle the image dimension problem as well as the image compression problem is the oversized images feature policy and the unoptimized images feature policy. That means that when you turn on this feature policy, if your images are either of larger dimensions that they should be or not properly compressed, you will get a warning if you're in reporting mode, or they will just not render if you're in enforcement mode. Sorry about that. Then for legacy image formats, it basically means that you need to serve all your images in optimized formats. For Chromium's case, it probably means WebP today. But as image formats evolve, it could mean other more advanced image formats. But basically, you get a warning if you're using JPEGs, where WebP would have been a better option, or PNGs. Unsized-media is a feature policy that basically enables us to avoid the relayout problem. So it turns off the fact that the browser relayouts the content after the image dimensions came in. So if your initial layout didn't match the image dimensions that eventually reach the browser will just not relay out, and content will not be displayed properly, and you will get a warning as part of the feature policy reporting. And in order to make it easier for people to actually get it right, we are adding an intrinsic-size attribute to the image element in order to be able to tell the browser what are the image dimensions, their intrinsic size dimensions ahead of time, as well as an aspect ratio in the case of responsive images. So you would be able to indicate both width and height to the browser ahead of time and avoid the relayout issues that are often a problem. And finally, there's work happening on lazy loading of images, where feature policy enables an opt-in to that mode, at least initially. So instead of implementing lazy loading of images in JavaScript, which many people now do, you will be able to use the browser's native lazy loading mode. And then for feature policies, the other big use case outside of improved image loading is restriction of powerful features. And there are many, many features that are included in that. Some examples are video, audio, WebXR, geolocation, payment requests, microphone access, speech API access. These are all things that generally are being abused by third parties, and you can, if you don't want that to happen, you can just tell the browser to turn them off for all your third parties. So those restrictions apply both to your own top-level iframe, so the first-party content, as well as any third-party iframe that is loaded afterwards. So that restriction propagates to all the child iframes. The second piece that was originally part of the CPP proposal is transfer size policy. Another problem we wanted to tackle is the problem of the fact that when users click on links, they have no idea what the actual cost of that link will be. Because in many parts of the world, mobile data is not necessarily free and unlimited. And clicking on the link today can easily result in a 100 megabyte download that the user never really intended or never really consented to. That may not be a problem when data is free, but it may be an issue when it's not. So we wanted to solve that with a policy that enables a website to declare a performance budget upfront and have the website delegate its budget to its iframes, or pieces of its budget to its iframes, so that the main content as well as third-party content will be restricted, and a budget will be enforced by the browser. But one problem that we ran into here is that This seemingly good idea at first is actually an enabler for some security issues because it enables the first-party context to know how much data the third-party contexts are loading. And by doing that, it opens up a bunch of security and privacy problems that, because generally it enables the first party to know things about third parties that it shouldn't, and enable malicious sites to know your login state, for example, to various social networks. There are various discussions about somehow limiting the budget to very coarse buckets and fuzz the actual download sizes in a way that doesn't introduce security issues. But it's very hard to know that this is clearly safe enough and can actually work. So this part, the transfer size policy, is still something that is on hold at the moment. And the third piece of the original CPP proposal is to figure out ways to tell the browser which content is actually important versus which content is less important, and have the browser change its both download priorities as well as execution priorities as a result of that. And that idea developed into the current proposal of priority hints, which enable you to tell the browser exactly that. So if you have, for example, a carousel where all the images are in the viewport, but some of them are hidden, that enables you to tell the browser that the visible image is of higher priority than the other ones. If you have cases where you're loading asynchronous scripts, but they are in fact important, you're just loading them as async in order to avoid blocking the rendering process, then you can also tell the browser that and avoid having the browser apply heuristics that, for example, assume that async scripts are not less important than other resources on the page that you're loading. So essentially, it enables you to rely less on the browser's heuristics and be more explicit about what's important and what's not. And if you're interested in more details, I recently co-authored a blog post explaining more about priority hints and what you can do with them. They are also going to origin trial, basically effectively in origin trial from a week ago as part of Chrome 73. So this is something you can try out in production right now and report back regarding whatever results it may give you and if it's helpful or not. We're desperately looking for people to try it out and let us know if it's any good or not in terms of real-life performance benefits. Okay, so we covered the content restriction parts, but as I said earlier, the secret sauce for AMP is really the privacy preserving prefetch. That's the piece that makes it blazingly fast by cheating. Essentially, privacy-preserving prefetch is a fancy way of saying that we're getting the content to the user before they actually ask for it, but without revealing that fact to the site's origin. And how can we support that kind of cheating on the web? It's tricky because it would mean that we need to load resources without their origins actually knowing about it, while still maintaining the concept of origins on the web. And origins on the web have traditionally been very coupled, the concept of origin, where who wrote this resource, who's authoritative for this resource, and who delivered this resource were tightly coupled, or are tightly coupled in the world of TLS. When we're looking at secure origins and the guarantees that TLS gives us, it provides us with guarantees regarding the resource's authenticity, integrity, and confidentiality, which are all things that are super important when it comes to credentialed resources, or to resources that are that may differ between different users. But if we remove that last big piece, if we now ignore credentialed content and just look at non-credentialed content that doesn't change between different users, we can effectively ignore confidentiality and conclude that authenticity and integrity are enough. In order for us to have those work, we don't really need to have the content delivered from an origin that holds the private keys for the content, that can sign the content on the fly as part of the TLS key exchange. But we can have the host sign the origin, sign the content ahead of time, and have any arbitrary host on the web deliver it, and still know that in terms of authenticity and integrity, that content was delivered from the origin we think it was. This mechanism for us to do that is sign exchanges. That's a standard proposal that basically enables us to decouple transport from authoritativeness and define a way in which the server tells the browser that the content is signed, doing that by adding a signature header that includes a digest of the content that is cryptographically signed with a special certificate of the origin. And the browser can have those guarantees then and can effectively display the real origin as part of the URL bar, have that content be considered first party for anything related to that origin. So it has access to that origin's cookies, it gets that origin service worker, etc. So it provides all the guarantees that TLS provides, but for non-credentialed content. And then we also have bundled exchanges, which is a related proposal that enables us to bundle multiple resources as a single package. Together with sign exchanges, that will enable us to deliver content from an arbitrary host, which includes the main document as well as all the related sub-resources that can also be loaded from that package. That piece is still not implemented, so it's still a bit, sign exchanges just shipped in Chrome 73. Bundled exchanges are still a bit further out, so this is something that's still being worked on. And also, another important component of privacy-preserving prefetch is prefetch. Link.rel prefetch has been around for years and is supported by some browsers, but not all browsers. It's defined as part of the resource hint specification, and its main purpose is to fetch resources for future navigations. That means that those fetches don't terminate when the user navigates away. It means that if the resource is not cacheable, it still survives in the browser cache for a short period of time. In Chromium, that's 5 minutes. But I mentioned before that not all browsers support prefetch, and one of those browsers is Safari, and they don't support it not because It's complex to implement. The code for the code supporting prefetch is already part of WebKit, but prefetch is not, as currently implemented elsewhere, is not compatible with their privacy model. And Safari's privacy model includes double key caching. That means that third-party resources are cached by using both their URL as well as the domain of the top-level frame that loaded them. So if you're loading the same resources from two different pages on two different domains, the cache will not be consulted for privacy reasons. And the reasons they're doing that is to avoid, to prevent third parties from tracking users. That means that if they were to support prefetch as it is right now, because prefetch is a resource that's being requested by one page and then cached in order for it to be used by another page, and those pages are likely to be on different domains, supporting prefetch as it is right now will violate their privacy restrictions. So in order to avoid that, we've been talking to Apple folks about modifying or defining a way where prefetch can work in a double keyed cache world. One of the restrictions we'll have to apply is that it will only be applied to documents. The reasons for that is that prefetching sub-resources can be used to leak information from one website to another, where if you have multiple prefetches that will be used as sub-resources, the website that will be using them can effectively use the cache state of each one of the sub-resources as a bit in some sort of a UID, so which it can and people do. So it would mean if we want prefetch to live in a double-keyed cache world, it will have to be restricted to documents. At the same time, we also understood that prefetching is like when we were talking about service workers and prefetching of sub-resources, we're not always sure which service worker should be applied to those sub-resources when they are being fetched, because the page on which we don't know on which page they will be used, and therefore we don't know the scope of the service worker, and there can be correctness issues there. So currently it looks like we may need to restrict prefetch to just navigation requests. And that means that in order for us to support loading of sub-resources in those scenarios, we need to use link rel preload. How many of you are familiar with preload? Thank you, Dan. So preload has been available in Chromium and WebKit for the last couple of years, and unlike prefetch, it's destined for preloading resources for the current navigation. The main purpose is to let the browser know of resources ahead of time so that it can start loading them earlier. So the reason we would need that is for those resources to, one example is that they require more processing. So for example, background images and fonts need the full CSS to be processed before the browser starts loading any of them. And preload gives us a way to let the browser know about them ahead of time. Another example is for dynamically injected resources that the browser's preloader cannot pick up from markup. So preload is a generic mechanism for us to do these kind of optimizations. But in the context of prefetch, it can also be used to make sure the sub-resources are there as soon as possible. And that can be as part of the content, or if we want them to start loading before the user has navigated, we can also use the link header form where we basically it's an equivalent to the markup variant, but can be used to tell the browser about resources as a header, which means that their processing can start a bit earlier. Now we can use preload with the media attribute in order to preload responsive, like preload resources in a way like they're only used for certain responsive breakpoints. We can use the type attribute in order to only preload resources of certain formats in browsers that support them. But there are still things that we cannot really do with preload, and specifically, we cannot really preload responsive images today. So images that are loaded with srcset and sizes. How many of you are familiar with responsive images and like srcset and sizes? Okay, cool. So I don't really have time to cover those in full, but just in a few words, srcset is an attribute that gives the browser a few variants of images with different resolutions or dimensions, and then sizes tells the browser what image dimensions what image dimensions is the image likely to be rendered at for various responsive breakpoints. And then this gives the browser enough information for it to pick the best fit in terms of image resources to download it and use it. And up until recently, preload didn't really have an equivalent capability. So for images that are loaded that way, there was no way for preload to do its thing and load them ahead of time. And a recent proposal basically adds those very similar attributes, only with different names, image srcset and image sizes, to the link element in order to have them be available for preload. So we define those new attributes, but with an identical syntax that can be used either in markup or header forms or of preload. And once we started thinking about the implementation of image srcset and sizes as link headers, we realized that the browser is not necessarily aware of the viewport the page will be rendered in at that point in time. Because we currently use this awful hack of the meta viewport in order to let the browser know what the viewport sizes will be. And that is only available after the HTML has arrived to the browser and was tokenized. But the headers are potentially available before, so it's a shame to wait until that processing happens before we start loading those images, before we send those requests out. So that is already a problem with preload when we're using the media attribute, which is also using the viewport sizes. But adding image srcset convinced us that it's a problem worth solving. So there's a current proposal to add a viewport header that will basically contain the same information as the meta tag, only in a header format that will enable us to tell the browser ahead of time what the eventual viewport will be, so that it can make the right choices when preloading resources. And the third component, I don't know how I'm doing on time, but yeah. The third piece that I wanted to talk about is user-centric metrics. Basically, we want to make sure that our users get good, fast experience, and we want to be able to measure and monitor that. And then we'll talk more about various monitoring APIs. But as part of the overall instant loading effort, we saw that many of the current APIs don't immediately correlate with user experience or require more processing, and we needed to give more direct correlation with user experience and the metrics we expose. So those areas that we want to focus on are paint, so knowing when things are actually rendered on screen, interaction, and knowing when the page is reactive to user input. And finally, layout stability, knowing that the layout doesn't move around after the initial rendering happens. For paint, we first started out with first Contentful paint and first paint, trying to show users, like basically when something was painted on screen, this is when we expose those timestamps, and there are many cases where this works well. But there are also other cases where this doesn't really, like when we ask real users if those metrics correlate to the point in time in which they think something meaningful happened, it's not always well correlated. And then we decided to focus on element timing, which basically gives us a per element timing entry that tells us when this element was rendered to screen or something as close to possible to that. So it will enable us to have a better correlation with something more meaningful that the user is seeing. And there are two variants to that. One is adding entries for elements that are that the developer has indicated that are likely to be important. So elements that annotated by the developer. And the other variant is to just register a few elements based on browser heuristics. The heuristics we're thinking of now are generally, like, for one example is large images. So if we have images that are larger than some percentage of the viewport, or the X number, like the X largest images in the viewport, we'll get an element entry that we can then propagate, gather with various analytic solutions, and report report as part of our general reporting, like performance reporting. And then for interactivity, we initially have long tasks as an API that exposes points in time where the browser is not interactive because it's doing some other long task. That long task is defined as a task that's longer than 50 milliseconds, and in most cases, that is probably some JavaScript execution where the browser doesn't have the possibility to yield to more important tasks such as user input. So that is a great primitive, but it doesn't give us the full picture. And we've played around with lighthouse metrics such as time to interactive, which indicate when the browser was first interactive and stayed interactive for a long while. So this is something that we can, for example, somehow prototype or polyfill using long tasks. And TTI is a great lab metric, but in the wild it suffers from bias because users, when users click on things, they often trigger JavaScript, which can then trigger long tasks, which can then mean that the TTI gets longer if users actually interact with the content. So we tried for a while to figure out a way to apply TTI to the wild, but it was too unstable to be useful. But event timing is the evolution of the same idea. So long tasks basically report times where your users may have had a bad time. Event timing report times where your users were actually trying to click your page and the page wasn't responsive. So any event which handling surpassed a certain threshold, which we're currently talking about 52 milliseconds by default, will get reported, and then you can generally feel better about yourself, and then fix it. The reason why only long events are reported is to avoid creating many entries that are not necessarily useful and increase the overall memory usage. And also, the values of event timing are fuzzed to the next 8 milliseconds for security reasons. One special event timing is first input delay, which we're thinking can be the next TTI in terms of reflective of the first experience. This is the time that the user first tried to interact with your page. And this report basically tells you if this was a good experience or a bad experience. And because this is a single entry, we're collecting it anyway and collecting and reporting it anyway because it doesn't run a risk of bloating memory. And finally, for layout stability, we talked about the layout stability problem. We're experimenting with a new metric that will basically report whether or not your layout was stable, so that a value of 0 would be good, means that the layout hasn't moved at all, and then will increase as your layout shifted around during the lifetime of the page. So to sum it up, instant loading is great. Users love fast pages, and nothing beats instant. Privacy preserving prefetch is a capability that will enable us to have the resources on the device before the user actually needs them. Content restrictions will enable us to have performance guarantees that the content will be fast and won't trigger any user experience anti-patterns. And finally, user-centric metrics will enable us to measure that the user experience is on par with what we think it should be. Thank you.